Hey guys, Mr. Middleton here. Today we're going to start our second unit, our reasoning chapter, and we'll talk about inductive reasoning. At the end of this video, you should be able to identify patterns and make conclusions based on those patterns, and you should be able to provide a counterexample to show a conjecture is false. Okay, there are two types of reasoning that we're going to look at in this lesson, and that is inductive and deductive reasoning. Inductive and deductive. Okay, we'll focus on inductive reasoning, but it's good to know about the second as well. Okay. Inductive reasoning makes generalizations or conclusions from specific observations. Okay, so here's an example. George Washington passed away, Muhammad Ali passed away, Michael Jackson passed away. Conclusion: all men pass away. Alright, so just based off the observations, you see that all men passed away, so all men pass away. Deductive reasoning makes specific conclusions from broad observations. Generalizations. Okay, so an example of deductive reasoning: every human eventually passes away. Steve is a human. Conclusion: Steve will pass away. Well, let's say eventually pass away. Sounds nicer, right? Okay, so Steve will eventually pass away. In this lesson, we're going to focus on inductive reasoning. The conclusion that we made above is an example of a conjecture. Okay, basically our guess. Have an educated guess. Based off of what we know, this is what we think. Okay, and these can either be true or false. So no matter what you think, there is an outcome. Okay, and proving a conjecture to be true is much more difficult than proving it to be false. Because in order to prove something false, all you need to do is to provide one counterexample, or an instance where the conjecture is false, or better yet, wrong. If you prove one counterexample, then the conjecture, your educated guess, sometimes people say, but we'll say conjecture, is false. So, here's a conjecture. All four-sided figures are squares. Okay, you can take your time and try that one out. If you want to wait until I go to this next one, so if you don't really think you know what a counterexample is, we'll look at it. Okay, let's do this next one together, though. All non-intersecting lines are parallel. Okay, from our last chapter, we know that that's not true. We're more familiar with parallel lines not intersecting, but now you guys should be able to answer that skew lines are an example of non-intersecting lines that are not parallel. So this counterexample shows that this conjecture has to be false, because skew lines are a thing. They don't intersect. They are not parallel. Okay, and so by this one counterexample, even though most of the time parallel lines, even though parallel lines are what we're most familiar with, this conjecture is false. Okay, so you kind of see that thinking. So if you haven't already, use that same kind of thought process to find the counterexample for all four-sided figures are squares. I'm going to flip to the back. Alright, so again, conjectures, we're observing a pattern, we're trying to guess the next or what's going to happen next based off of our observations. I'm going to flip to another page so I don't get the bleed through. Alright. So, make a conjecture about the pattern in each sequence, then use your conjecture to find the next two terms. So you have 3, 6, 12, 24. What pattern are we observing? Hopefully, there are a couple different things, a couple different paths that you could take, but as you look through it, I think you would be able to see what's happening. So maybe I'm looking here and I say, okay, well, they're adding 3. Okay, and then does adding 3 work? Nope, adding 3 does not work the next time. Okay, that path doesn't work. Okay, multiplying by 2. Multiplying by 2. Multiplying by 2. Okay, multiplying by 2 does work in all the instances that I've observed. So my conjecture would be that you multiply by 2 each time. Okay, and so now I'm going to guess the next two. 24 times 2 will be 48. 48 times 2 will be 96. Alright. And now the next one we have A, C, E, G, I. It looks like B, C, D, E, F, G, H, I, J, K. So it looks like you're going to skip a letter, every other letter. In alphabetical order. Alpha, I'm going to abbreviate that. Okay, alphabetical order. And so the next two terms shouldn't be that hard to find out. J, K will be written down. L, M. Look at that. Two great letters. Alright. Okay, hopefully you observe those patterns, and that makes sense by checking what we saw and making a conjecture. Now, the tough part about these conjectures is it makes sense of why our answers were what they were. Okay, but to prove something that has not happened yet, these are educated guesses. Okay, so it could be that what we've observed up to this point changes next, but it's smart for us to say this is what's happened in the past, this is what we would expect to happen next. Okay, not always right, but that's probably the best way at it. Okay. Example. This table shows how many regions are created inside a circle when there are a certain number of points placed on the circle. Okay, so 2 points, 2 regions, 3 points, 4 regions, 4 points, 8 regions, 5 points, 16 regions. Alright. How many regions would be created by 6 points on the circle? Alright. And so, looking at this, they gave us, we have a diagram of 1, 2, 3, 4, 5, 6 points. So there are two ways that we can try to solve this problem. Okay, we could count every single region that is on this diagram, or we can find a pattern in what we know and make a conjecture about the six point. Alright, so I'm going to choose to find a pattern because I really feel like if we count it out, it's going to be a lot. Okay, and I'd rather work smarter than harder. So as we look here, when there's 2 points, there's 2 regions. 3 points, there's 4 regions. 4 points, there's 8 regions. 5 points, there's 16 regions. I know that this on this left side is just increasing by 1 each time. So the next one should be 6. The pattern that's happening on the right side, well, each time we're multiplying by 2. Times 2 here, times 2 gives me 8, times 2 gives me 16. It makes sense to me that that pattern continues. Okay, times 2 gives me 32. So, how many reasons would be created by a 6-point circle, or by 6 points on the circle? 32. Okay, and if you don't believe me, you can count it. Alright. Alright, so, hopefully, then, you are able to identify patterns and make conclusions based off those patterns, and provide a counterexample to show that a conjecture is false. We'll do some more practice problems, and I will see you guys Wednesday.